Welcome to this video on binary addition. Okay, so we all know how to add some numbers. Let's firstly have actually a look at denary decimal addition firstly. If I had two numbers, let's say 64, and I wanted to add to 28, okay, so 4 plus 8 equals 12. I know that I've got 110, 2 units, 12. 6 plus 2 is 8, plus the 1, the carry, so I know that 64 plus 28 equals 92. And I know that because I know that in the base 10, so the denary number system, I've got a 1 column and I've got a 10 column. Okay, so when we're adding in decimals, we do tend to add these columns down and we add them to 10. So we say 4 plus 8 equals 12, 6 plus 2 equals 8. However, it's not really 6 plus 2. What you're actually adding here is 60 plus 20. Okay, 60 plus 20 is 80, plus the 10 we've got down here is 90, because 9 is obviously in this 10 column, and it's going to come in handy in a minute. So back to binary addition then. Let's just give ourselves some binary numbers, and to be quick and easy I'm just going to use a nibble. That's half a byte, 4 bits, just so that it saves me time writing them down. So I've got 1 0 1 1, and I want to add that to 0 1 0 0. To add these, all I need to be able to do is add up to 2. So I've got 1 plus 0 equals 1. 1 plus 0 equals 1. 0 plus 1 equals 1. 1 plus 0 equals 1, which actually gives me this number here. Now that's nice and simple. However, it becomes a little bit more difficult when you add two binary digits and end up with 2, because obviously there is no 2. So let's have a look at a situation where that may occur. We've got 1 0 1 1, 1 0 1 1. 1 plus 1 is 2. Now in binary, 2 is 10. So I carry the 1 and put a 0 in this column here. So 1 plus 1 equals 2, which is 10, 1 and 0. 1 plus 1, okay, plus 1 equals 3. 1, 2, 3. Now 3 in binary is 11. So I put 11 here. 0 plus 0 is 0, plus the 1 is 1. 1 plus 1 equals 10. So obviously it's a 2. Carry the 1 and the 0. Now here, remember in lesson we talked about I've run out of space here. I do not have enough bits to be able to store this number, and this is what they call stack overflow. That may well come up in the exam, and you would need to indicate that you were aware that the number would result in a stack overflow error. I'm now going to show you another way of adding binary digits, and this is where the numbers along the top will come in handy. I'm going to use different coloured pens so you can see this different method. Okay, so I've got my digits here, but I'm going to be adding them slightly different. So let's give ourselves some numbers. This time I'm going to put the column numbers along the top here. So we know we've got 1s, 2s, 4s and 8s. This is our 1 column. 1 plus 1 Okay, we know that 1 plus 1 equals 2. Now that would mean I've got 2, which means if you look at this column here that says 2, I've got 1 lot of 2 and 0 lots of 1. Okay, now these are 2's in this column. 2 plus 2, so I've got 1 lot of 2, I've got another lot of 2. 2 plus 2 equals 4, plus another lot of 2 equals 6. 2, 4, 6. Now because I've got 6, it means that I've got 1 lot of 4 and 1 lot of 2. So you can see this is a slightly different way of working it out. So let's have a look in our 4 column. 0 lots of 4, 1 lot of 4. Okay, so that's 4, and I've carried a 4 here. So that's 4 plus 4, which gives me 1 lot of 8. So I put the carry over here. Let's have a look in my 8 column now. I've got 1 lot of 8, which is 8, and I've carried another lot of 8 here. 8 plus 8 is 16, which means I have got 1 lot of 16 and 0 lots of 8. Again, I've resulted in a stack overflow error here. So that's a different way of adding those binary numbers. Keep watching, I'm just going to go through them with 8 bits. Oh, 8 bits. Yeah, 8 bits, 1 byte. So let's make up a number. We've got 0, 1, 0, 1, 1, 1, 0, 1. Okay? 1, 1, 0, 0, 1, 0, 0, 1. So let's do it the first method first. So we've got 1 plus 1 equals 10. Remember, 1 plus 1 is 2, 10 is 2. So I'm just going to show you down here. So look, we've got 0, 0, that equals 0. You see that? We've got 0, 1, 1, 1, 0, 2, 1, 1, 3, and then what I need to do is shove that over, gives you 4. Okay, and then obviously you go on from there. Back to the sum. We've got 1 plus 1 equals 10. 10. 0 plus 0 plus 1 gives us 1. 1 plus 0, 1. 1 plus 1 is 10. 1 plus 0 plus 1 gives us 10. 0 plus 0, 1 gives us 1. 1 plus 1 gives us 10. 0 plus 1 plus 1 gives us 10. Again, I'm not doing this on purpose. We've got stack overflow again. Let's try with the other method this time. So using the orange pen this time to show you that this is a different method, this one. So we have got 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 0, 1, 0, 0, 1. This time I am going to use the columns. I'm going to put that in a different pen so we can see them on the screen. 1, double it, double it. So we're doubling it every time. Okay. We've got 1 lot of 1, another lot of 1. Add them two together, that gives us 2, which means I've got 1 lot of 2, 1 lot of 2, 0 lots of 1s. So have a look at this column here. I've got 0 lots of 2, 0 lots of 2, 1 lot of 2. Okay, so that's 1. 4, 0 lots of 4, 0 lots of 4, 0. Now in my 8 column, 1 lot of 8 plus another lot of 8. So that actually means I've got 16 now. So I'll put marker in the 16 column under here and a 0 in the 8s. Now the 16 here, this is where I'm going to have to get on my maths. 16, one lot of 16 and another lot of 16 carried, that gives me 32. So I'll put 1 in the 32 and 0 here. Let's have a look how many 32s I've got. One lot here plus another lot here, that gives me 64. 64. I've got one lot, I've got one lot down here, that gives me one lot of 128. 0 lots of 64 and 128. I've got one lot and another lot, that gives me 256. So again, unfortunately, I've resulted in a stack overflow error here. But you can see how this one is slightly different by using the top ones. This one here, this particular method, will help a lot more if you are adding 3 binary numbers. That will make it make far more sense, and I'm going to show you why. Let's go back to having 4 bits. 0, 1, 0, 1, 1, 0, 0, 1, 1, 1, 0, 1. Let's add these together now. But again, I'm going to use the columns. We've got lots of 1, lots of 2, lots of 4, and lots of 8. I've got 1, 2, 3 1s. Okay, 3 times 1 is 3. So that means I've got one lot of 2 and one lot of 1. Somebody looks at how many 2s I've got. 0, 0, 0, one lot of 2. So I'll just put that in there. So how many 4s I've got? 4. One lot of 4, another lot of 4. 4 plus 4 gives me one lot of 8. How many 8s have I got? 0, 1, 2, 3. Okay, so I've got 8 plus 8, which is 16, plus another 8, which gives me 24, which actually gives me one lot of 16 and one lot of 8. Again, stack overflow, not doing it on purpose, it just happens to be the numbers that I'm choosing. That is how you add in binary. Have a practice with some of the examples from the learning platform and see how well you do.